So, hello Teresa, can you hear me?
Yes, I can hear you.
Okay, so welcome Teresa to the big global data conference. We are honored to have you here. This is a business track and Teresa Escrig is an architect at Microsoft. She'll be sharing her insight why transparent AI is the only AI that can be trusted. So um, before starting this, there is a Q&A box where you can post your questions for Teresa, and there is a chat option also available where you can share any resources or any other comments for Teresa or any other organizers. So now we start. Teresa, can you briefly introduce yourself and then start the session, please?
Yes, absolutely. Thank you for having me here to the Global Big Data Conference. It's my honor. My name is Teresa Escrig, and I'm a senior architect at Microsoft currently. Although the work that I'm going to present here doesn't represent necessarily the opinion of Microsoft, it's my own. So this is the disclosure. So I don't really represent the work that we have done in responsible AI at Microsoft, although I'm working in that area there as well. But this is work that I've done prior to joining Microsoft. And the topic is a very large one. We have been talking about how the black box type of AI cannot be trusted for long enough. And what I want to do in this talk is to specifically talk about the challenges that means and go beyond the problem statement only and provide solutions as well. So that's what is this presentation about. So the main challenges that I observe for executives to harness the benefits of AI is, among others, that there is a lack of understanding of AI, and that the consequence of that is that only less than 15% of the firms report that they have deployed AI capabilities into widespread production. And that's a very low number. And more than 70% of the firms still define that the big data adoption is an ongoing challenge. There is also a lack of strategy for defining what is the ROI from AI investments. So 80+% of companies have invested more than $50 million in big data and AI in 2020, but only 17% of the companies have an AI strategy, and many of organizations lack the foundational practices to create value from AI at scale. The other challenge that I've observed is that the AI control is not in the executive hands, but in the data scientist hands. And that's a problem because the 75% of the AI decisions having a business impact. It impacted business processes, or talent development, or customer experience. All of those are CEO concerns. But the decisions of what data set is used and what ML models are being developed are in hands of data scientists, I think in the wrong hands. The other challenge is that there is fear, there is a lack of trust, there is a fear to unintended consequences of an unproven technology. And in my opinion, it has a justification to have that fear. The AI algorithms have to comply with GDPR and the California data privacy law. And 67% of CEOs think that automation and AI will have a negative impact on stakeholders' trust. So trust is a big thing. And then the fear to be disrupted by startup is the other challenge that I've identified. The startups move faster with adoption of new technologies and solving business challenges that the large corporations might be slower to approach. However, the value of AI that is locked is really large. It's still seen as 15.7 trillion by 2030, when with manufacturing, professional services, retail and financial services as the main industries where that value resides. The current state of AI is we compare artificial intelligence with natural intelligence, and the natural intelligence, the human intelligence, have been evolving for 500 million years now, from reptilian to middle to neocortex brain in a very slow pace. And artificial intelligence has a little over 60 years of history, since 1956, and a very rapid growth. The point of intersection between human intelligence and artificial intelligence is called general AI or singularity. Probably everybody knows that. We are still in narrow AI before arriving to that point, and superintelligence will arrive very quickly after general AI arrives. So my point in all my presentations is, let's make sure that we don't arrive to general AI, that we remain in somehow a narrow AI that is always under our control, and hopefully helping us to enhance our own natural intelligence a little bit more than just linear growth. So according to the experts, and a survey that was done to AI experts, 87% said that singularity will happen in the 21st century, and that will have a huge impact. There is two groups of people thinking in opposite ways of if it is good or not, the happening of singularity. There is a group that says that the AI will solve all our problems, and there are another group, and I'm part of the second one, where we say be careful of what we develop, because if it is more intelligent than we are, as Elon Musk said, we might become the cat of the house. I want to mention that the boom of AI has happened with machine learning technologies. But machine learning is only one set of AI technologies. And I put it here in the left corner of the big bubble. Deep learning belongs to machine learning technologies, but there are others that were developed in academia from the same time as machine learning was developed, that has 60 years of history. And some of them have been also applied to the industry, not as much as machine learning. And the reason why machine learning flourished was because we were able to read more than naturally intelligence performance into applications, computer vision and natural language processing. But there are others that are also they have a whole history of research, like qualitative modeling, knowledge graphs, on ontologies, decision trees, case-based reasoning. In particular, knowledge graphs are being exploding right now, when we have discovered that machine learning might not solve all the challenges that we have encountered within the field of machine learning. And I'll talk more about that in this talk. If we consider the AI technologies within the purple circle here, there is the concept of capabilities, which is what can we solve using those AI technologies, like, for instance, natural language processing or computer vision can be solved using some set of these technologies. And we can change those technologies that we use to solve the problem of computer vision, for instance. That capability will be the same, but solved with other technologies when we discover that something else works better than what we are using currently. Like service robotics would be another one, or edge computing. Those are capabilities. And then the combination of those capabilities can solve applications. For instance, autonomous vehicles is an application. It's one of the ones that have more advanced AI in it. Precise agriculture will be another one. Digital twins will be another one, the predictive maintenance, for instance. I like to have always this slide to explain what is a neural network in a very basic way for everybody to understand why we tell people that it's a black box, and also to demystify what it is and what it does. So it's node in neural network. We have several structures here to the right. A node is a mimic, is a copy in a functional way to the human brain cells. We have 100 billion neurons in our brain, and it has dendrites, like if it was input, then the nucleus, the axon to transmit the electric impulse, and the buttons that communicate with the next neuron. In the same way, or in a similar way, that's how it works the node of a machine learning model. We have inputs, for example, that can be the images of an autonomous car. And then within the node, we have an addition of a multiplication, and that's a basic mathematical equation within the node. And the multiplication includes the weights of each one of the inputs, which is a reflection of the importance of that input into the node. And that calculation is done, and if it goes higher than a threshold, it activates the next neuron, the same way as we will activate the next neuron in our brains. And there is many structures for neural networks. The one that is used the most in computer vision and natural language processing is the deep convolutional network. It has a structure like this, and in each layer you have thousands of nodes. So you only control the input, and you see the output and change the parameters, which basically are the weights to the importance of the input, and with that is the only thing you control in a machine learning algorithm, in any of the structures, and that's why it's called a black box, because we really don't know what is done within the neural network. I want to talk now about a few examples of AI going wrong. So I said that computer vision using deep neural networks or convolutional neural networks had better than human performance, and that's why it's used. However, it's also easy to hack. It has challenges that are not the same as we have with our human vision. For instance, if we overlay an algorithm to detect what pixels have been used to identify a boat in those two images, we perceive that the pixels used for object recognition in those two images were not the ones that characterize the boat, but the reflection of the boat on the water. And this example is also kind of scary. So for autonomous vehicle, if we have a stop sign with a shade, or some pixels, some stickers and some pixels missing in the stop sign, the machine learning model will give us 100% accuracy that the identification of the stop sign is a speed limit 45. So that's really not good when we have a car that is only seen through the deep learning algorithm model. And another example is when we train a model to see jellyfish, and we provide as an input dogs, a picture of dogs, the model is going to perceive jellyfish, whatever is the input that we give. And there are many more examples here. I'm not going to go over them. If you get the slides, you can read them. there are many examples of AI going wrong, and that has a cost also, basically in the brand of the company that is using an AI that can go wrong. These examples here are not necessarily all examples of technology going wrong, also of bad decisions of companies and how that affected to the brand and the value of the brand, and how risky that can be when you use an AI model that works not well with people. And what I wanted to mention or highlight in this slide is that MIT said that AI will bring serious risk unless you approach artificial intelligence as a strategic imperative. And another important thing that MIT said is that we can build these models, but we don't know how they work. In fact, machine learning algorithms are a theoretical art and not a science. And I like this one particularly. It's very old, it's from Karl Popper in 1934, but it's very current in this moment for the way the machine learning algorithms work. Prediction from observation can only be verified. It cannot be verified. It can only be falsified. And we see that in the autonomous vehicle examples, when the cars are have been testing on the roads for years, and nobody still knows the maturity of those algorithms. So they have, in fact, said that the autonomous vehicles will be on the road and then retracted themselves because they are not ready. And we really don't know how the machine learning algorithm evolves and when it's going to be ready and secure. And that's the autonomous vehicle is the most advanced industry using AI, but they are all scaling back. All the companies doing autonomous vehicles said one thing at some point, and they are retracting afterwards when they realize that their speed of algorithm development is not the one they expected. The risk with this that I see is that it has happened many times with AI. We think that we have it sooner than we do, and we have the risk to go into another AI winter when we have too much of a high and don't deliver on the expectations. I think the prior speaker was talking about that too. So research that Accenture Technology Vision did in 2018 was that 72% of more than 6,000 executives thought that transparent AI-based decisions and actions are the only thing that can gain customer trust. So with all these challenges that I've been saying so far, I want now to start talking about the solution and not only staying in the problem. I think the problem is quite known at this point, and I want to say that since the last 3 to 5 years, the machine learning community has been working really hard on providing ways to open that black box. They call it white box, or explainable AI is called as well. And I want to compare what is explainable AI that can be accomplished with machine learning versus what I will call transparent AI, which is the topic of this speech. So the most advanced example of explainable AI that I've seen is the one developed by NVIDIA. It's an end-to-end solution for autonomous vehicles. And oops, going back. End-to-end because you provide the images of an autonomous car into a deep learning algorithm that is represented here to the left. And the outcome is the 3 actuators, which is steering wheel, accelerator, and brakes. And they overlay an algorithm to define what pixels from the input to the deep learning algorithm was used, what pixels were used and were relevant for each one of the images that were entering the algorithm. And the result was those green pixels that we see here in these three images, which in our human driving perspective are the correct pixels to be focused on when we drive. So we will focus on the extremes of the road or the center of the road, the extremes of the cars that are facing us, if we were considered to be the autonomous vehicle. So we think that the computer vision model that is included in this end-to-end solution for autonomous vehicles is working properly because they are focusing on the right pixels. So that's explainable AI at its best as far as I've seen. However, we still don't know why the car is making any decision based on those pixels. We don't know the context of the car and why the car is turning or accelerating or stopping or anything, any action that the car is making at the moment. So we, on the other hand, transparency will be explaining that context. So to know how to do transparent AI, we need to compare natural and artificial intelligence and go a little bit into theory. So both natural and artificial intelligence starts with perception, which is understanding the context of what we are thinking about. Sensory integration will be we use more than one sense or sensor, and reasoning happens when we think about what we are observing and making as many inferences as we can, which is what we also call thinking. And these three aspects of intelligence are being implemented in AI, in artificial intelligence, with a set of AI technologies called, with the name knowledge representation and reasoning, which contains technologies like qualitative modeling or ontologies of graph databases. And in natural and artificial intelligence, once things repeat itself is when we learn. We have machine learning for the learning aspect, and we have other aspects of intelligence as well that we don't need to go on now because we are still not even able to integrate those at the very bottom. So in my point of view and with my experience with practical examples, transparent AI can be achieved when you integrate knowledge representation and reasoning with machine learning. And I will give a couple of examples in the next slides. So transparent AI, in my opinion, is the first pillar for a responsible AI framework, and it's one of the most important ones. If we don't have transparency, we'll not have responsible AI. But there is other aspects of pillars. One is how we relate people and AI and how we do brand and AI. And the last one will be do the AI strategy. And so the executive level will do the AI strategy and create your own AI in a way that is benefiting the company and instead of fearing it. So those are the components of responsible AI. Those are the two examples I was talking about transparent AI. One was for autonomous vehicles, where you had the context of the other cars around the autonomous vehicle, which is represented here with the blue arrow, and the available decisions for the autonomous vehicle with the context and the explanation of each one of the decisions made by the car based on the context of the car, what other cars are around, which ones are closed, what lanes are, and what actions we can take. The other example is for DNA sequencing using unstable data. And it was a company that had developed a chip for DNA sequencing with nanopore technology, and they didn't have stable data. They tried to do machine learning twice and failed because of that. And qualitative modeling was a good solution for them. They got 84% accuracy on non-supervised classification, when by naked eye, they only got 30%. So the other aspect is people. So one of the most important things for responsible AI is the design of the product that we are developing using technology. That will also be for non-AI. So what we develop that always enhances human capabilities of all the stakeholders that are being affected by that technology is something we need to consider at the beginning of any implementation. And if we use AI for our customers and that AI contains ML, we need to be careful of not using biased data to train our models, because we are going to amplify the bias that we have with our historical data in the new customers. And we also need to make sure that the ML behaves as intended once it's being used, it's being deployed. So monitoring is really important. And for our employees, AI and automation is going to displace jobs. It's not going to substitute, it's going to enhance and change jobs, but in any case, it's going to disrupt. So we need to help them to move on into the next thing that is going to be beneficial for the companies and prepare the workforce of the future in the company. So be prepared for that. And regarding brand, these technologies, AI is risky, the same way as cybersecurity is a risk. So we have to make sure that we comply with regulations, and GDPR and the California Privacy Act are the first ones. Hopefully others like the GDPR will fall, because the most important thing GDPR says is that the data subject possesses the right to access to meaningful information about the logic involved, which is the intuitive explanation or the intuitive transparency behind an AI engine decision. But we also have to have a brand sentiment analysis and a brand risk plan for the case when something goes wrong. As we know, with ML is easy that something goes sideways. When the data changes with respect to the data used for the training, the ML model will not work. And we need to be ready for that. And the last thing is how to create your own AI is doing AI maturity assessment of basically the data strategy. If you have all the data in place, not necessarily to train machine learning models, but to get insights and start the AI journey with that. And then defining the AI strategy, which is how you want to your company to evolve in 1, 3, and 5 years, without taking into account the technology, how you want it to evolve, and then use the technology to make it happen, and not the other way around as it is happening right now. And leave always part of it, which is for new business models, because in my opinion, AI is going to give most of their value not from improving the current processes or services, but by uncovering or doing something new that we now don't even know. So the benefit of transparent AI is that shows causality, the why, in an intuitive way for all stakeholders, not only for data scientists. It also maximizes functional safety and cybersecurity. It accelerates development, especially because it facilitates quality control and reduces time and cost of algorithm development, and increases trust, which is, I think, the most important thing in AI. Otherwise, we might develop very beautiful models, but never use them because we don't trust them. So I know I'm almost over time. I'm open to questions right now, and I also want to say that if you are interested in digging more into those concepts, I wrote a book not long ago called Save AI in Amazon.
Thank you, Teresa. So there is just one question in Q&A Will you be able to see it?
Let me go and see if I need to go.
Oh, you just have to click on the Q&A. It's right down at your screen.
Yeah, but I have the slides covering all my. Stop sharing. Now I see it. Okay. Training. Do you think about training QA models? What do you refer by QA models? Like qualitative models? I don't understand the question. So if you guys can clarify the question.
Ritu, can you please clarify your question?
What is QA models?
Ritu, are you there to clarify the question, please? It seems Ritu is not
Or
there.
Ritu is asking if you can hear me. No, we cannot hear you. So can you type even in the chat this question for prior? Oh, it was the question for prior session. Okay, then that's why I didn't understand it.
Oh, okay.
So if there is no more questions, thank you again for the opportunity of talking. And if you guys want to reach out to me, my email was at the end of the slides, and I'm also in LinkedIn. You can reach out to me in LinkedIn.
Thank you, Teresa. Thank you for your informative insights. So this session will conclude our first day of the Big Data Conference, and hopefully we'll see you all tomorrow. We'll start tomorrow also at 8 a.m. with the workshop, and then we'll go through different business tracks and technical tracks and mentoring sessions. So please join us again tomorrow. And meanwhile, also post on the social media websites with the hashtag Global Artificial Intelligence Virtual Conference or Global Big Data Virtual Conference. Thank you all to attend and join us in this session.
Bye, everyone.
Bye. Thanks, Teresa.
Thank you, Nero.